I'm giving a talk with the title Scaling Network Management Tools. I realized that representing a network of 200 nodes is probably, in this context, in this meeting, a bit ambitious title. However, we have some tools developed which we have done for ourselves, and what you are seeing now is a picture of a network covering the Norway. This is a load map, not very uncommon. This one was made in '97. It's what you see is a geographic auto-scaling network map system. UNINETT is the academic network operator of Norway, and some of the links here are, about 2.5 gig. So it's a small, fairly normal network operator. So I just give you this information so that you can understand in what context we develop our tools. So why do we make our own tools? We started out fairly early after the SNMP came with the NiceNet tools that were quite early on the market. They were nice, but they were a bit static and cumbersome to use and didn't cover all our needs. So we started looking at commercial platforms that we were expected to develop tools that would be usable to us. But they seemed to be solving the wrong problems. We met them year by year and told them what we wanted, but they never came back with anything useful. They had centralized operations, they were intranet oriented, they had poor history functions, they were huge, so not really useful. And then we looked at our own resources. We had hackers, we had students, and we had open software. So we decided to make our own tailored tools. And in this process, I have deduced that we have used some principles to develop this software that we did not find in those commercial tools we looked at. And one of them are the, let's say, properties that these systems should have is accessibility. We have a very distributed organization covering multiple places, multiple organizations. We want to communicate with users, the customers, operations, engineering, services. Even the board of directors are interested to see how the network performs. The tools need to provide trends so that we can see many of those, let's say, users need to see what's happening on a long-term scale. To do planning, to do whatever. You need to support hundreds of customers, devices and links easily. It means we need summaries, we need the threshold monitoring, we use tables, we sort, we get the bad values on top. This is fairly simple, but in fact this was not available to us as far as we have been seeing when we started doing this. The thing has to be dynamic. The SNMP index changed all the time. We could not track our data on a long-term basis. It must be usable. The access has to be quite easy. The big platforms, locked up everything in a Windows machine in the basement with the operators. We decided to be visual quite early, and graphs, maps, and animation is complementing the tables. And we want to be open, both using open software, and we also want to share our own tools at a bigger community in order to grow our own portfolio of usable tools. So I already mentioned network maps. We have geographical maps. We have schematic hand-drawn maps, which with automatic fill-in of load. We also have a comprehensive campus management system with auto-detection. Here's an example of the handmade or the hand-drawn type of load map that is quite nice for complicated topologies. We have this campus management system that is made by the University of Trondheim that is scaling quite well. It auto-detects, it keeps tracks of MAC addresses and makes comprehensive statistics. It's used by all the universities in Norway and it's increasing popular. So it's all made by some, it's quite simple principles that are behind this. The netmap map system that is doing geographical maps may generate suitable clickable maps from a topology database, so you don't have to care about how the maps look like. Breaks down the topology down to suitable maps, and it's based on UTM coordinates. So here's an example of you can zoom in our network you can zoom into about 50 different areas, and here's the location in Trondheim where we live. It's just as an example. I guess we skipped the part with measurements. You all know why we do measurements. We try to integrate with the University of Trondheim, so and cooperate with them on a Center for Quantifiable Quality of Service. So we want to work with researchers in order to make them help us find interesting problems in the network. We also work at the European level and projects to develop tools to further our network management control. We work on passive monitoring and on a passive measurement platform at 10 gig. We also have a few SNMP tools that we started developing in the 90s. A comprehensive link management system that has all the scaling properties with tables, graphs, aggregation, and area analysis. It's also scaling because you just point to router and it will collect all the statistics. And the scaling mechanism here is that the IP address and the link name are mapped together from a description field in the router. Someone earlier today, or I guess it was yesterday, asked how do you make operators, do things you want with these tools, and it's not easy. But this is one of the things they, in fact, are able to do. They are able to set the bandwidth on the link and the description field, and we just pick up this information from the router together with the SNMP data, and then we can automatically put into a database that we can recognize and follow a link name as it changes through the routers to a new router, get a new SNMP index, and so on, fairly easily. So we don't need a lot of manual intervention except the simple rules for configuration. We also complement this with a more general SNMP polling package that have the scaling properties of handling lots of devices in tables, but can zoom down to having more or less nice graphs. You can't manage hundreds of devices by hundreds of pictures. You need to have some, let's say, extraction of data, interesting data, before you dive into a single graphs. Here's an example of a table report that are sorted on the average values. We compute the busy day. This is a week. We compute the busy day and the peak samples. So we have, to some extent, some statistical computation also. Depending on the tool, we are then able to make graphs, and in this case we also make context graphs, so you can see for this week we can see the CPU utilization of a router. This is during the same month, and this is for 1 of days in the week. So we can scroll and see the context. There's also a status monitor that is fairly light. Uses the same simple list of routers that the previous polling tools do. It's got a very simple, but let's say just trouble ticketing system that is just scalable. It's got a fine-grained downtime prediction. It's got the same link identification mechanism we talked about. And we are able to provide availability statistics that are accepted by PTTs as documentation of violation of SLSs. Here's the user interface to this status monitoring system, which has a clever sorting algorithm that always keeps the important cases on top. In this case, there's just 3 Olav incidents. There are no red incidents in the network at the moment. So we here have operational state and downtime and identify the components. So this is our operational center main screen. We also monitor the quality of network with a ping tool. I realize that there are some ping tools out there, but I feel that I haven't seen anyone that does the, let's say, follow the scaling properties which I went through in the same way. That is, it's polling targets in parallel at the control rate. It's has got some statistical handling of data, so that you can have some basic properties there, like standard deviation, medians, 90 percentiles, stuff like that. That you like to see your where your values are concentrated. So you also get the plots and tables that I mentioned. You have the percentiles, you have the median, the max, and you have the packet loss shown in one table. You can sort it on what you like, and then you can, in that way, the operators can, let's say, once in a while, each morning or whatever, go through this list and see what are the trouble devices today or yesterday. You can, of course, graph over time the delay and the packet losses. And you can have a graphical distribution plot. This one, these statistics are for the 6net that was mentioned in the previous talk, and this is more or less showing the speed of light down to Europe, whereas the closest host would be 1 to 10 milliseconds, and the Nordic would be 30 to 40, and Central European members would be 50 to 60, and then Eastern Europe would be a bit higher. So it's not really interesting in this context because this network is not very much loaded. We also have made some tools for what we call micro measurements. That is, we started to get interested in what is the let's say, what's happening in a sub-second interval, because most of the flows are on a high-speed network sub-second, and to have a good response on your web page, you need good performing sub-second let's say, responses. So far we have discovered that the routers really doesn't allow us to do that, because they have a update frequency of it's about 1 to 15 seconds, dependent on manufacturer and depending on the card and revision of cards. So we didn't get much there. So we use passive monitoring cards and try to see what's happening on a small scale. And here's a graph that shows us 1 millisecond and 100 millisecond resolution on the polling. Not very much interesting, really. You see that the 100 microsecond intervals are sometimes empty on a 300 megabit per second loaded gigabit Ethernet. We will find, though, a loaded link sooner or later. So this was just a preliminary test. We're also working on developing a flow generation tool in connection with the passive monitoring cards. And we also try to make this tool with these scaling properties. We hope to contribute this tool to the which is based on flow tools to contribute this to the flow tools package. It's made with PostgreSQL, and we do aggregation and statistics in the database. And also do it multi-user because we want to share the flow of information with our customers, and some part of it could be sensitive. Here's an example of a graph from this system. Very much like the flow scan, and I guess we are quite motivated by those nice graphs. And well, to sum up the tools, and we have them. We have the link status monitor stuff is available. It's quite high quality. It's quite usable. The Mping stuff is also available. The Scampi tools, which are with the flow generation stuff, will be released later this autumn. The micropole stuff is there, it's just a few simple scripts. The general plotting package is available, but not very much, let's say, made ready for big scale use. And the netmap system, we will need some time to document before we release, and we are not decided to release that yet. There's also a map viewing client that we also are still not having finished. Thank you. And we will use a GPL-ish license. So it's essentially free, but there's a redistribution clause. So I have time for a small demo. I thought I would like to show to you a map showing system. This system can zoom to, let's say, any interval, and the squares you see popping up when I walk around is possible zooming areas. We have loaded the database with statistics for the last 5 years so that we can see how the load has developed. We have put the CPU load for hours, which will be shown in these points. We have the point size tells you the size of the delay. So this is a satellite link up to Spitsbergen. And I thought I just, and the colors shows the load, whereas the thickness of the line shows the capacity, and the size of the, yeah. So, by network, yeah. So we can see the dates here, watching the traffic in UNINETT in September. This also comes in 5 minutes resolution, so that you can see what's happening today or yesterday. This is, I guess, most for fun, but at least one of the professors at university told us he could use this for teaching routing to the students. So that's all I would like to show you now, and
So we have time for a couple of questions, and looks like Avi, you've been extremely patient over there.
Just waiting till the end. That's what you should do, right?
There you go.
Okay.
All right.
One question that I had, since you're looking at doing passive monitoring to actually generate flow data, is have you been looking at the performance aspects of what you could do with that? So doing TCP state reconstruction and looking at loss on a per destination prefix basis to be able to take that in to say, these are the places I'm actually having performance problems, as opposed to waiting for users to call you and say, hey, I'm having performance problems, and then looking at your routing based on that. Because I've been looking for a cheap box that can do that. There are plenty of $80,000 boxes that can do that. But
Yeah, one of the aims of the project was to have a cheap box. That's a fairly standard PC or a high-end PC.
Right.
We realize that can be able to transport packet headers
Right.
at 10 gig, and that you need a fairly fast bus. So we have concentrated on the basic issues here, that to get this packet header stream up to the flow generation program in an efficient manner using memory mapped I/O and stuff like that.
right, and then the question is getting some very cheap state analysis software to look at retransmits and throughput and stuff like that, and then maybe make a proprietary protocol export format, which is flow plus some performance information on some of the flows. That would be interesting.
Okay, yeah. We haven't thought of any complex flow generation, let's say, problems yet. We are in the phase of looking at the design of the flow generation.
Okay, so it looks like we have a break, and we start up again at 3:15. Thanks, everyone.
Thank you.